In today's lesson, we are going to be focusing on reviewing quadratics. So what we're going to start off with first is looking at the properties of quadratics. So this is going to focus on some of the main key features of a parabola, which is the graphical representation of a quadratic, and some of the key values that you may have to look for or solve for. So first is the axis of symmetry. This is a vertical line that passes through the vertex, and basically it's that imaginary line that divides your parabola into two equal halves. A vertex, the vertex is where the axis of symmetry and the parabola meet. So again, that axis of symmetry, that vertical line that we talked about, is going to go through the vertex, and the vertex is at its highest or lowest. So that's where our parabola is highest or lowest. The optimal value is the y value of the vertex, and it is either the minimum or maximum point of the parabola, so it's either the minimum or the maximum value. So it just depends on how our parabola opens. If it opens down, then it's going to be a maximum. If it opens up, it's going to be a minimum. The x-intercept is where the parabola crosses the x-axis. And a parabola can have 1, 2, or 0 x-intercepts. It all depends on where it's placed. And the x-intercepts are also known as the zeros or the roots. So if you have a question that's asking for the zeros or the roots, keep in mind that that could just be looking for the x-intercept. Finally, the y-intercept is where the parabola crosses the y-axis. So looking at a parabola here, we can kind of see some of those key features. We see our parabola in blue, that U shape. We see our axis of symmetry that divides it directly in half. We can see our vertex down here, so it's right at the middle, or the lowest point of our vertex, but it's also directly in the middle, and we can see that that axis of symmetry goes right through it. We can see our two roots where it crosses the x-axis, so in this case, this parabola does have two x-intercepts, or two roots. We can see the y-intercept where it crosses the y-axis, and the maximum or minimum we can see from the actual point of the vertex. It's the y value, and it is a minimum because it is the lowest point. So again, that's just the key features or the key characteristics of a parabola or quadratic. In the first example, we are going to just look at, again, learning to identify those key parts. So again, looking for the vertex, it's the highest point, which in this case is right here, which has the x value of 1 and a y value of 8. So our vertex is 1, 8, 8. The direction of the opening is down. We can see this opening is down here, so it's opening down, as well as the arrows on our parabola are pointing down. The axis of symmetry is that imaginary line that cuts our parabola in half. Because it's a vertical line, it's in the form x equals, and the x value comes from the x value of our vertex. So in this case, our axis of symmetry is x equals 1. For the steps we didn't really talk about in the previous one, but we have talked about them in the notes or the previous notes. The steps, we can figure that out by starting at the vertex, move 1 to the right, and then we have to draw a line to our point or to our quadratic. When we draw a line to it, we want to count how far do we go up or down, and that's going to be our first step. So in this case, we go over 1 and we end up going down 2. So our first step is -2. From there, we take 1, or we move 1 over to the right again, and we go down until we hit our next point. And in this case, we're going down 6. So that's our next step. Finally, from that point, we go over 1 again, and we go down again until we hit our quadratic or our graph. And we should find that we're going down 10 this time. So our steps in this case are -2, -6, -10. You could also do this going to the right or the left, as well, and it will be the exact same thing because again, remember that our quadratic is symmetrical. The optimal value of our quadratic comes from the y value in the vertex. So in this case, our optimal value is y equals 8. And because our graph opens down, this is going to be a maximum value. For x-intercepts, we can look at where it crosses the x-axis. We see two of them. So our x-intercepts are going to be -1 and 0 is the 1 point. And the other point is 3 and 0. So those are the two x-intercepts. And finally, the y-intercept, we can see where it crosses the y-axis. In this case, it's 0, 6 is our y-intercept. For the second example, I want you to try this on your own, so I suggest pausing the video to try this on your own, fill in the missing information, and then we'll come back and check your solutions. So, trying it on your own, these are the solutions that you should have come up with. You should have found that the vertex was -2, -3. It was opening up. The steps were 3, 9, and 15 we could get, or we could determine, because again, the general form, and we have this in our notes previously, is 1 times A, 2 times A, or sorry, not 1A, 3A, 5A. So from figuring out the first step was 3, we determined then that our A value is 3. So 3 times 3 is 9. 5 times 3 would be 15, which would be our third step. So even though we can't see that on the graph, we could determine that. The axis of symmetry, x equals -2. Again, we get that from the x value of our vertex, as well as we draw our imaginary vertical line. E, our optimal value, it comes from the y value of the vertex, or -3, and it is a minimum because it is opening up. So it is that lowest point. The x-intercepts are -3 and -1, and our y-intercept is at 0, 9. So again, those were the key points of this quadratic. Moving on to the different forms of the quadratic. So we are going to look at the 3 forms that we've covered in this unit. The first is the vertex form. So the vertex form is y equals a, x minus h squared plus k. The a value controls the direction of the opening as well as the step pattern. So again, we talked about if a is positive, it opens up. If a is negative, it opens down. And again, it helps us with that step pattern, which was that 1a, 3a, 5a that we just talked about in the last question. H tells us the x value of the vertex, but specifically it's the opposite of the number that we see, only because the general equation already has minus. So if we subtract a positive, that means our answer, or our equation should say the negative, or minus. If we're subtracting a negative, it would change to positive. So the h value tells us the x value of the vertex, which is also the axis of symmetry, and k is the y value of the vertex, which is also the optimal value, which is the max or min. So those are the 3 things that the vertex form tells us. And if we were given the quadratic or the quadratic equation in vertex form, it can be changed to standard form by expanding. So this is where we use the FOIL or box method, and we will talk about those and go through some examples of expanding later on. Factored form. Factored form is an equation in the form y equals a x minus r times x minus s. The a value again is the exact same thing as it was in the previous equation. It still tells us the direction of the opening and the step pattern. R and S tell us something different. R and S, or more specifically the opposite of these values, because again, same thing as it was in the last one, because the equation is originally minus, when we subtract a positive value, it will look as though it's subtraction or minus. If we are subtracting a negative, it will change to a positive. So the R and S, or opposite of what we see in the brackets, represent our zeros, or our x-intercepts. So the factored form helps us figure out the x-intercepts. And we've talked about previous examples, and we've done it in our notes as well, where once we find those x-intercepts, we can find the vertex. So the factored form can be converted to standard form by expanding, so similar to the vertex form. And as well, it can be converted to vertex form by determining the vertex and using the a value that we're already given. So again, we have looked at previous examples like that in our notes. So again, if you want more explanation on that and some examples, please go back and look at the factored form lesson. Finally, standard form, y equals ax squared plus bx plus c. The a value again, so that first number that we see, again tells us the direction of the opening as well as the step pattern. So that stays the same throughout all equations. And then our c value tells us the y-intercept. So this is where the parabola crosses the y-axis. So not a lot of information in this one, but if we needed to, the quadratic or a quadratic in standard form can be converted to factored form by factoring. So if we really wanted to, we could factor this equation, go back to factored form, which was this one, and from here we could work our way back to vertex form. So we should be able to convert between all three if we really need to. What we're going to look at in these examples, though, is how to determine the equation. So we're going to look at how to determine the equation given specific information. So looking at the first one, we want to find the equation in vertex form of the following parabola. A vertex of 2, 8, and it goes to the point of -1, -19. So what we have to do here, or what we're given, we are given our vertex, which tells us h and k, and we're given a point, which is just x and y. Because we want to find it in vertex form, our form should be y equals a x minus h squared plus k. Because we know our h and k, we could plug those right into our equation right away, but we're still missing our a value. So if you go back up to that last page, every value or variable or letter that you see highlighted, that's what you need to fill in if you're asked to determine an equation. So the only thing we're missing from vertex form is the a value. However, if I plug everything in, the h, the k, the x, and the y, if I plug that into my equation, I can solve for my a value. So what I'm going to do, every number here is associated with a letter. I'm going to replace each letter with that number. So y will be replaced with -19. A I still don't know. X will be -1 minus h, which is 2 squared, plus k, which is 8. Now I'm going to work through solving. So -19 equals a. -1 minus 2 is -3 squared plus 8. -19 equals a. 3 squared is 9 plus 8. So now I want to solve for a. So I want to move things over to the other side. I'm going to move the plus 8 first. When I move it over, it becomes -8. So I get -27 equals a times 9. To get a by itself, I'm going to divide both sides by 9. -27 divided by 9 is -3. So that is my a value. So once I find that, I can rewrite my equation. Y equals -3 for a, x minus 2 squared plus 8. And that's the equation of this quadratic. So I've plugged in a value for a, h, and k. The x and y we don't have to worry about. And now I have my equation. For number 2, it's going to be the exact same idea, except we're dealing with factored form. So factored form is y equals a x minus r times x minus s. So in this case, we're given a different formula or equation, and we're given some different information. We're given the two x-intercepts, which should be our r and our s value if you go back up and look at that first page. And the point still gives us an x and y. So we're going to do the same thing, except where we sub in the values, except we have a different formula or equation that we're subbing it into. But the process is still going to be the same. So instead of y, we're going to write 3. A we still don't know. X is -1 minus r, so minus -4, times x, which is -1, minus s, which is 2. I'm going to go through and simplify. So -1 minus -4 becomes -1 plus 4. So we get 3 times -1 minus 2. So -3. 3 equals a 3 times -3 is -9. To get 9 by itself, to get a by itself, I'm going to move the -9 over, and it becomes 3 divided by -9 equals a, and I get -1 over 3 equals a. Now that I have my a value, I can write out my final form, or factored form, so y equals -1 over 3, because that's my a value, x minus r, so x minus -4, which becomes x plus 4, times x minus s, which is 2. Now this becomes my final equation. The last example, here I have standard form, and I want to find the equation in factored form, then vertex form. So the first step that I need to do, if I want to go to factored form, I need to factor this. Because I have a value in front of the x squared, that means I have to common factor that out. So if I common factor it out, I'm going to take the -1 and bring it outside. Then in the bracket, I'm going to divide every term by -1, which is only going to change the signs. So it becomes x squared minus 4x minus 5. Now, in the brackets, I can divide that, or I can factor that. So factoring, we looked at different ways. I'm going to use the product and sum method. So I'm looking for two numbers that multiply to -5, and the same two numbers have to add to 4. The nice thing about this, the two factors, there's only two numbers that can multiply to 5, which is 5 and 1. Because it's -5, one of those numbers has to be negative. So which one makes sense? Well, if I make -5 and +1, and I multiply them, that does work to -5. And if I add them, they work to -4. So this is the right combination. Once I find my two numbers, it becomes y equals -1, x minus 5. So x is the first term, minus 5 is the second term, and we have x and then plus 1. So these two factors just go right into that equation. This is now my factored form. To find the vertex form, I need to find the vertex. So in order to find the vertex, I need to know where it's located. And luckily, because I have factored form, I know two key points that will help me. And in this case, the two key points are the x-intercepts. So the x-intercepts are going to be 5 and -1. The opposite of what we see in the brackets. Because my x-intercepts are 5 and -1, we know on either part of my quadratic, at -1 and 5, I have my x-intercepts. And if I want to find my vertex, I know that my vertex is going to be directly in the middle. So I need to figure out what value is in the middle of 5 and -1. To figure that out, I can add them together. So 5 plus -1, then divided by 2. I get 4 divided by 2, x equals 2. So I know that my vertex is going to have the point of 2 and then something. To figure out what that y value is, I can take that x value and substitute it back into the equation and solve for y. So y equals -1. Instead of x, it's going to be 2. So 2 minus 5 times 2 plus 1. And I'll rewrite the actual original equation actually up here. And now this just becomes a calculation which I can solve. So -1 times -3 times +3. And I get y equals, in the end, -1 times -3 is +3, times another +3 is +9. So I know that my vertex is 2, 9. Now, to write out my equation in vertex form, I have my h, I have my k. My a value I can get from the factored form or the vertex form. Because again, the a value is always the same. So for vertex form, it'll be y equals -1 x minus h, so -2 squared, plus k, which is 9. So here is my vertex form. Again, this may be long and complicated, but we have covered this in class and we have gone through other examples like this. So please go back and look at those lessons if you need more examples. What we're going to look at now is expanding. Expanding is the opposite of factoring, and it's used to go from factored or vertex form to standard form. There's two different methods that we talked about. Whichever way you choose to do it is up to you. I'm going to show you both methods. So in the first one, we have x plus 3 times x plus 4. So if I'm using the box method, I'm going to create a box with 4 squares. I'm going to put one bracket on top, so x and +3, x and +4. Each box is going to represent we're going to treat this like a multiplication table. So x times x gives me x squared, x times 3 gives me 3x, 4 times x is 4x, 4 times 3 is 12. So these are all the different pieces of my final answer. The other thing we have to be aware of, though, is that there are going to be like terms, which will always be these diagonals. So I can just collect all my like terms. So I have x squared, which I can't really add to anything. It's on its own. So x squared, 4x, and 3x combined to give me 7x. And then 12 is on its own. And that's the expanded form. And we can see that it's very similar to standard form. For the FOIL method, it's going to be something similar, and you may have learned this in grade 10 as well. So again, if you're comfortable using this method, it's up to you. But FOIL means first two numbers in the brackets multiply, the outside two numbers multiply, the inside two numbers, and then the last numbers of each bracket. So that gives me x times x, which is x squared, x times 4, which is 4x, 3 times x, which is 3x, and 3 times 4, which is 12. I still have two like terms right in the middle. I get x squared plus 7x plus 12. So whichever way you choose to do it, is up to you. For the box method, again, for the next example, x minus 3 squared, it's going to be the same thing. However, we don't see two brackets, but keep in mind this squared means that x minus 3 squared is x minus 3 times itself, x minus 3 again. So we now have our two brackets. So for my box, x and negative 3, x and negative 3. Again, treat the box like a multiplication table. The two diagonal ones should add up. So when we simplify, we have x squared. Negative 3 plus negative 3 is negative 6x, and then plus 9. If we want to do the FOIL method, again, I'm going to write my two brackets. I'm going to show the arrows just to know that I make sure, or just so I can double check to make sure that I'm multiplying everything correctly. X times x is x squared. X times negative 3 is negative 3x. Negative 3x plus 9. Two like terms in the middle. I get x squared minus 6x plus 9. For the last example, we do see our two brackets, but there's one extra step. And so we will take that into consideration. So I'm going to use the box method first to multiply my two brackets together. So x minus 6 and x times 4. X times x is x squared, negative 6x, 4x, and negative 24. So here, when I simplify, I have x squared. The two diagonals is negative 2x and minus 24. So I've multiplied the two brackets together, and I've gotten x squared minus 2x minus 24. I still have to keep in mind that 2 is multiplying that answer. So this 2, I still have to keep in mind or take into consideration. So I've done x minus 6 times x plus 4. Now that answer I have to take and multiply it by 2. So here, this 2 is going to be distributed to each term. So that means 2 times x squared, which is 2x squared, 2 times negative 2, which is negative 4x, 2 times negative 24, which is negative 48. And that's my final answer. For the FOIL method, it's the same thing. I'm going to write out my full equation or expression. So x minus 6 times x plus 4. I'm going to do the FOIL method first on my two brackets because I should be comfortable with that by now. So I get 2 equals x times x is x squared. X times 4 is plus 4x. Negative 6x, negative 24. If I wanted to, I could multiply the 2 through to all of these terms, but I might as well simplify the bracket first just to make it a little bit easier because there will be less terms that I have to deal with. Now we see that we're at a similar step to the last example. Sorry, I'll underline the like terms that I added together. And now 2x squared minus 4x minus 48. So again, it doesn't matter which way you choose to do it. Whatever way you choose to do is fine as long as you show enough work and you get to the same answer in the end. The last thing we're going to look at is factoring. And we've already kind of done this a little bit in one of the quadratic equation questions, but we're going to look specifically at just factoring right now. So again, factoring is the opposite of expanding. So there are two different directions of a pathway you could think of. Expanding is going one way, factoring is going the other. And we use factored form to go from standard form to factored form. So if we want to go from standard form to factored form, we have to factor, which we have done already in this lesson. So again, I'm going to show you two different ways. Whichever way you choose to do is up to you. The reverse box method is a little bit more of a trial and error type thing. But what we're going to do is, because we know our box is going to be set up like this, we know from the patterning when we do it, x squared is always in this box, and that last value at the end is always going to be in the corner. So the only way I can get x squared is if I have x times x. So now I need to think of, okay, well, what two numbers multiply to give me -4? And there are a couple options, so how do you know which one is correct? Well, because we know from adding these two terms, we always got the middle number, which in this case was -3x. So the two numbers I find that multiply to -4 have to add up to -3x. So two numbers that multiply to -4 but add to -3. And in this case, it's -4 and +1. So that means that outside my bracket, this spot would have to be -4, this would have to be 1. And we do see that x minus 4 times x plus 1, this does give us the right information. So now I know what each bracket is, x plus 1, x minus 4. For the product and sum method, it's a little bit more straightforward, but you're basically doing the same work. So if I have x squared minus 3x minus 4, I'm looking for two numbers that multiply to give me -4, and two numbers that add or give me a sum of -3. Those same two numbers, have to give me -3. So here again, you're going to use more of a trial and error. You can use a multiplication table to help you figure out what numbers you're looking at. You want to start off with what numbers multiply to -4. It's a lot easier than what numbers add to -3. If you think about -4, your options are 4 and 1, or 2 and 2. Because it's negative, one of them has to be negative and one of them has to be positive. So if I look at the second example of 2 and 2, if I make one of them negative, that does multiply to -4, but it doesn't add to -3. So I know right off the bat there, those ones won't work. So if I'm looking at 4 and 1, this is my only other possibility, but where does the negative go? If I put it on the 1, -1 times 4, again, is -4, but -1 plus 4 is +3. Since that's the case, I have the right number, wrong sign, I'm going to move the negative to the other one. And again, that's fine because all we're doing is just kind of trial and error right now. And this does work because if we just double check, -4 times 1 equals -4, -4 plus 1 equals -3. So once I find my two numbers, which I have here, I just put them into the brackets with x. So x minus 4 is 1, x plus 1 is the other one. And that's factored. Second example, exact same thing. Now, I'm going to start with the box method. I know x squared has to be first, so that's x times x. 42 is the other one. And I know that the two numbers that multiply to 42 also have to add to -13. So what numbers multiply to 42 but add to 13? And when you go through trial and error or just some guess and check, we should get -6 and -7. So that means my brackets, one will be x minus 6 and one will be x minus 7. Because when we do have a positive, but they have to add to a negative, chances are that we have two negative numbers. So x minus 7, x minus 6 is going to be my factored form. And the same thing is true if we do it in the product and sum method. It's the same idea. two numbers that multiply to 42, but they add to negative 13. So when we go through and do our factors, it's negative 7, negative 6. You can test this. Negative 7 times negative 6 equals 42. Negative 7 plus negative 6 equals negative 13. So that does work. So then we get x minus 7 and x minus 6 as our two factors. The last example is going to be a little bit different because we have a value in front of the x squared. So this is different from all the other ones. That 2 makes it different. But what I can do is I can common factor this. And common factor basically means just dividing out the same number. So if I look at this, I want to take out that factor of 2. So I'm going to take it and put it outside the bracket, and I'm going to divide every term by 2. So 2x divided by 2 just becomes x squared. Sorry, 2x squared divided by 2 is x squared. Negative 4x divided by 2 is negative 2x. And 16 divided by 2 is positive 8. Now what I can do is I can factor what's in this bracket. So in the bracket, again, if I'm doing reverse box method, I know x squared has to be first and 8 has to be on the bottom. So we get x and x. So now I'm looking for two numbers that multiply to 8 but also add to negative 2. If you work through and you think about it, you should get 1 is negative 4 and 1 is positive 2. So that means negative 4 will be 1, 2 will be the other. I now have my two brackets, x plus 2 times x minus 4, but we still have to take into consideration that 2, so that 2 is still out in front. And that is our factored form. The same process is going to be true if we do the product and sum method. We're still going to factor out that number in front of the x, that 2, divide everything else by 2. If I use the product and sum on that first one, two numbers that multiply to 8 but add to negative 2. Again, going through the trial and error, I get negative 2 or negative 4 and 2. If I want to check, negative 4 times 2 equals negative 8. Negative 4 plus 2 equals negative 2. So that does work. That means one bracket will be x minus 4, and the other one will be x plus 2. And again, that's our factored form. So again, multiple ways to do it, but essentially you're doing the same concept, or you're looking for the same patterns. It's just how do you prefer to organize your information. So again, for the concepts of quadratics, this is kind of an overview of them, of looking at the properties, how to find equations, how to expand, and how to factor. For more in-depth examples or explanations, please go back and look at the previous lessons, as well as there are some other lessons or concepts that we don't really cover here in this review, but you can find them in the lessons as well.